Hello boys and girls and Cougar parents. Today we're going to work on adding and subtracting numbers that are in scientific notation. Let's take a look at a few sample problems together. Okay, let's look at our assignment where it says adding and subtracting scientific notation. We're going to work on number 1 and number 2 together. The key thing, whether we're adding or subtracting, is we have to have a common power 10 number. And here I have 2 times 10 to the third power plus 5 times 10 to the fifth power. Now I don't have a common power 10 number. Here I have 10 to the third and here I have 10 to the fifth. Well, I'm going to make commonality here by doing this. And you might say, well, you can't do that. And correct, if I were just to stop there, I'd totally change this expression. But if I tag on the 10 to the second power that I took away from 10 to the fifth power, this is all legal. It's all legal. If I multiply 10 to the third power times 10 to the second power, that's going to take me back to 10 to the fifth power. But instead of multiplying my exponents, I'm going to multiply 10 to the second power, which is really 100 because it's 10 times 10. I'm going to multiply that by 5 and look what I get. Now I have 500 times 10 to the third power. And now I'm going to bring down this part of the expression, 2 times 10 to the third power. And now I can add these because I have a common power 10 number. I can add my 2 and my 500 together and I get 502 times 10 to the third power. That's what I have when I add these together. I just add my base number together and my power 10 numbers stay the same. Now, is this scientific notation? No, because in order for this to be scientific notation, my base number has to be between 1 and 10. 502 is way too high, so I need to move my decimal point 2 places over, which will be 5 and 200ths times 10 to the fifth power. Because if I want to have to kick this back out here, I'm going to have to multiply that by 10 to the second power to move it 2 places over, and then I want to do 3 more. So that's my final answer for this addition problem. Pretty funky. Now let's take a look at this over here. Over here I'm subtracting. Once again, I need to have a common power 10 number. I have 4 times 10 to the 8th power, and over here I have 9 times 10 to the 7th power. 10 to the 8th and 10 to the 7th are not common, but I'm going to make them common. So I'm going to take this and I'm going to divide out a 10, and I'll have 4 times 10 to the 7th power times 10, okay? Because if I multiply this 10 times 10 to the 7th, that'll give me my 10 to the 8th. But once again, instead of multiplying it by my exponent, I'm going to multiply it by my base number here, and that'll give me 40 times 10 to the 7th power. And then I need to bring down that part of the expression down here, and I'm going to subtract 9 times 10 to the 7th power. Again, I combine my bases. 40 minus 9 will give me 31, and my power 10 stays the same. Okay, is this scientific notation? No, it's too high. I need to move this over 1, and now I have 3.1 times 10 to the 8th power, because I need to kick this out 1 to get 31, and then I need to have my exponent be a 7. Let's look at 2 more examples. Down at the bottom of the page we have numbers 7 and 8. 7 we're subtracting, 8 we're adding. Once again, we want to take a look at our power 10 numbers and find a common. I think I have a 10 to the 6th power and 10 to the 4th power. 10 to the 6th power is going to be my common, so I'm going to, well, I should say 10 to the 4th. I need to change this to 10 to the 4th power. And I got to keep this expression the same, so I have to multiply that by 10 to the 2nd power, because 10 to the 4th power times 10 to the 2nd power will give me 10 to the 6th power. So haven't broken any math rules, didn't change this expression at all. I just stretched it out a little bit, I expanded it. And I'm going to multiply this 10 to the 2nd power, which is really 100, 10 times 10, times the 1, and that will give me 100 times 10 to the 4th power. And then I'm going to subtract this guy over here, bring down that math information, this part of the expression, which is 8 times 10 to the 4th power. Okay, now I can subtract these since they have the same power 10 number, 10 to the 4th power. And when I go to subtract 8 from 100, that'll give me 92 times 10 to the 4th power. Once again, this is not in scientific notation. 92 is too high, so I have to change it to 9.2 times 10 to the 5th power. It's not that difficult, it seems a little weird at first. Let's take a look at 8. We're adding here. And I have 5 times 10 to the 9th power plus 3 times 10 to the 8th power. 10 to the 8th power is going to be our common power 10 number. So I'm going to bring this down and change this to 5 times 10 to the 8th power times 10. Okay, still the same expression as this first part here in parentheses. I'm going to multiply this 10 times the 5, which will give me 50 times 10 to the 8th power. Now I can add the second expression here, which is 3 times 10 to the 8th power. The 50 and the 3 will give me 53 times 10 to the 8th power. And my 53 is too high for scientific notation. I've got to change my base then to 5 3/10 times 10 to the 9th power. And that will be my final answer. I hope this was helpful. As always, I hope that was helpful, and if you have any questions, please bring them to class tomorrow. See you then. Bye-bye.